In this video, I am going to provide a physical understanding for what a derivative is, and provide some rules for differential calculus. The video will then conclude with some common notation. First, what is a derivative? A derivative is a measure of a rate of change. If I had a function like f is equal to x squared, and I took the derivative, I would get f prime is equal to 2x. What this tells me is the rate of change of the function of f at a given value for x. For example, at x is equal to 1, f prime is 2. The derivative is a kind of measure of the function's sensitivity to change. For example, suppose instead that the function f represented my displacement for some time interval. What f prime would represent then is my velocity. Taking the derivative again would yield an acceleration. Or perhaps you're a chemist interested in the rate of a reaction taking place in a beaker. Differential calculus, together with integral calculus, form the major branches of calculus. This is an important topic because calculus is widely used within STEM. There are several different rules for taking derivatives you might want to familiarize yourself with. First, the derivative of a constant is 0. The second rule is called the power rule, where if you have something that looks like this, f is equal to a times x to the power of n, the derivative can be found by this. For example, f is equal to 3x squared plus 8. Derivative of a constant is 0. If you have the addition or subtraction of one function to another, this is how you take their derivative. The product rule is a rule for taking the derivative of several functions multiplied together. Here is an example. The quotient rule is a rule for taking the derivative of a function divided by another function. Here is an example. And the last differential rule for this video is the derivative of e to the x is just e to the x. Here is some common notation. These are a matter of preference and convenience. If you have some function f, you may write the derivative as df over dx. When you see the df over dx, you may say to yourself, the change in f with respect to a change in x. Or you could write as f prime. The second derivative would then be, or in the case where it goes beyond the third or fourth derivative, you won't want to keep writing the prime, and instead you may put a number in place of the prime to indicate the number of derivatives. Placing a dot above a function, such as this, is typically used to indicate a time derivative. However, it may be used to indicate a different variable, such as x. It is something you'll pick up by the context of the problem, where it should be stated ahead of time. A final mention is a different kind of notation called Euler notation. It's not very commonly used, but it looks like this. And if it's multivariable calculus, you may denote the variable in which you're taking the derivative with respect to and a subscript. Finally, here are some examples to practice if you would like to try these rules out for yourself.